is really because when I look at the ratio of one of these terms to its predecessor, or maybe my a sub n, plus 1 to my a sub n, this fraction is basically acting as a ratio. And so I think this ratio test is nothing more than a disguised version of the geometric series test, which says if an absolute value is your r is strictly less than 1, you converge. If it's bigger than 1, you diverge. If it's equal to 1, you diverge. Well, with the geometric series test. Here, if that ratio is equal to 1, actually, to be honest with you, this particular test says nothing. It's inconclusive, and you're going to have to give up and rely on some other test. But this is the ratio test. It is so important. I have to take time off that clock to look at some examples. Let me take a peek at some examples. I think when it comes to example number 19, if I were to try to employ the ratio test, I'd be taking a peek at the limit as n increases outbound of the absolute value ratio of the n plus first term to the nth term. Is my first example, so I'm writing way too much. I think this is nothing more than limit as n increases outbound of my n plus 1 minus 2 over my n plus 1 squared plus 3n plus 1 plus 4. Divided by my a sub n, which is the same thing as multiplying by its reciprocal. That would be an n minus 2 downstairs, and an n squared plus 3n plus 4. But this will give me nothing more than a limit, as n increased that bound, of my n minus 1 times stuff. All over an n squared plus, I'll skip it, times an n minus 2. Do you guys think you can calmly relax and just guide the limit? I asked, do you guys think you can calmly relax? Well, yeah, it's just simply 1. So what does the ratio test say? It's inconclusive. Ratio test says the limit is strictly less than 1, I converge and do it absolutely. If this limit is greater than 1, for free, I diverge. If the limit is equal to 1, it's inconclusive. Guys, yes,
so
David.
In this case, would you use the alternating series test?
Yes, I would. Okay. As a matter of fact, from now on, you guys check this out. If your a sub n is a rational algebraic expression in n, the alternating series guaranteed to give you 1 each and every time. If your a sub n is purely rational, then it's guaranteed the ratio test is not going to be conclusive in answering the question. You have to rely on something else. In this case, I admit, I would use the alternating series test, and it works. We converge. Ooh, here's a nice example. And take a peek at example number 20. Let's take a peek at the limit as n increase that bound. Of the absolute value of the ratio of a sub n plus 1 to a sub n, you guys, I'm not going to write the absolute value bars. I'm just going to get rid of the negative notion of it. And I think a sub n plus 1 looks like this. However, divided by a sub n, inverting and multiplying, I think gives me this. You guys tell me if I'm throwing too much math D on the board. And you guys, if I'm going to try to evaluate this limit, don't you think I should maybe, I don't know, take some shortcuts? Maybe cancel my 3's, my 3 n's. And that's barely going to give me the limit, as n plays this game of a 1/3 times stuff. I don't know, what's next? Say it again, I'm so sorry, say it again. What about it? I was hoping you guys just say this. why don't we just multiply top and bottom by 2 to the negative n? Oh, sorry, I said negative n. Perfectly legal, I'm just multiplying a funky looking green form of 1. It's just that diving inside and committing to my math D skill set. I think that leaves me with, I don't know, is that a 2 plus 5 times 2 to the negative n? Over 3 times 1 plus 5 times 2. Is this helping you guys or not? I ask, is this helping you guys or not? Yeah, helping a lot.
Yeah.
So what's my conclusion?
Why couldn't you have said that the top is 2 times 2 to the n plus 5, and then that cancels and then it'll figure it?
Oh, only because I didn't have a factor of 2 over here. That's why. I was just being careful with my math D and showing that it really is true without hand waving. What's my conclusion? It converges.
Absolutely.
Absolutely. You're absolutely correct. That being the case, to say that it converges absolutely means really what? It means really what?
That it converges.
Means that not only does this converge, but it converges without the sign changes. Do you know what, you guys? I think in my example right here, I wasted your time. I think here, choose an example where I did not have to use a ratio test to validate that this series converges. Give me another technique.
Geometric.
Where's the geometric series?
Well, the 2 over.
No, I like what you said. Run with it.
2/3.
Okay, you know what, you guys, you are right. Because I think this is nothing more than sum. Is that a negative 2/3 raised to the n plus another sum, which is 5 times negative 1/3 to the n? And I think those individually both converge as geometric series with r being less than 1 in absolute values. And so I think you're right. I could have just as easily looked at these as a sum of 2 geometric series, each of which converges. Now I think the one thing you see within the sum that almost guarantees that you want to employ the ratio test is when you see factorials. When you see factorials, a dead giveaway, you really do want to use a ratio test. Dave?
What if that was 2 and minus 5, and then when you distribute the negative, you'll have that's the less than 1. Never
You
mind.
know what? That's just fine. You can even keep the negative sign there and put a negative or subtraction operation up there. It's fine. You just get 2 convergent series being subtracted.
I was thinking, what if 1 converged and 1 diverged?
Whenever you have the sum of 2 series, where at least 1 diverges, the whole thing diverges. Well, I think my next example is by far the best in my list. Let's take a peek at the limit as n plays this game of the ratio of a sub n plus 1 to a sub n in absolute values. If you guys don't mind, if I suppress this switch, everything else is positive, now I can suppress my absolute values. But let's be careful of notation. I think a sub n plus 1 is obtained by taking what you see inside this big green circle and very selectively, surgically replacing n with n plus 1. What's next? Thank you. Next to fix my mistake. I said surgically replace n with n plus 1. This ends being multiplied by 2. So I think replacing no tricks this time with n plus 1 gives me really this. Or like you said, sir, 2n plus 2, same thing. I think downstairs, I have this. Now if I divide by a sub n, or can I just cut the chase? It's just like multiplying by reciprocal of a sub n. I think it just simply gives me an n factorial squared upstairs. And a 2n quantity factorial downstairs. Seriously, everybody, no tricks this time. This is the limit I want to evaluate. And if you guys don't mind me coming in very briefly and rewriting, I'm probably writing too much in this example because it's such a good one. You guys, my math, do you okay? And if it is okay, how about rewriting this as a limit, as n plays this game of a big fraction? And when I dive in and carefully discuss this big fraction, I see, how you get ready, that I've got a 2n plus 2 times a 2n plus 1 times a 2n factorial. Those three factors are an alternative name for this one term. I used the wrong word, sorry. The collection of these three factors is equivalent to that one factor up there. Now, I suppose I've got an n factorial upstairs in blue. Oh shoot, I forgot there's another one. I meant to say another n factorial in red. Let's talk about downstairs. N plus 1 factorial, is that the same as this? Oh, yeah, you're right. I've got a bunch of terms. I missed my times n factorial. I'll put it in blue. I think when it comes to this n plus 1 factorial, same idea, isn't it? That can be interpreted as n plus 1 times maybe a red n factorial. And I think the only thing remains standing is maybe a purple thing that I'm referring to as 2n factorial. Do you guys see why I'm using all my color?
Beautiful.
And I think in the end, I'm merely left, after some cancellation, with the ratio of this product to this product. Do you guys think I'm done? Do you think I'm done?
Close.
Oh, I think I'm done, absolutely. No, I think I could be done correctly. Sorry, thank you. Which, by the way, is strictly bigger than 1. Therefore, by the ratio test, I diverge. Did you guys maybe not write it down? I'm just trying to save some time on the clock. David.
When you do the ratio test in that particular manner, are you always going to get cancellation to an n factorial and disappear? And if you don't, did you do it wrong?
I'm just reluctant to say every time, but that's why I use the ratio test with these factorials, because I typically get cancellation all over the place. Typically. Oh, you guys, what else do I have on the sheet? I really don't know. I need to look. I got a few. Shoot. Darn it, guys. I want to skip a few. And 22 is just way too nice. May I? So do you guys think you allow me, just on the clock, just 2 more examples? Just 2. And I'll stop talking today. Take it and peek at number 22. I got an idea. Suppressing absolute values and therefore suppressing the sign switch. Everything else is positive. Let's just write it in. I think a sub n plus 1 clearly is my n plus 1 factorial over my n plus 1 raised to n plus 1. I think in dividing by a sub n, I can interpret that as multiplying by the reciprocal of a sub n. So let me just multiply by the reciprocal of what you see next to the negative 1 to the n power. That would simply be n to the n upstairs over n factorial downstairs. Yes or no response? Are my math skills okay here? At least upstairs. Downstairs, are my math skills okay? Two yeses. Nice prime number, I'll stop there. And I think with a tad bit of cancellation, I'm now left with a limit as n increase that bound of, I don't know, what is that thing, 1 over n plus 1 raised to n. Any ideas?
Show more steps.
Okay. You mean from here to here?
Yeah. What happened to the top? Yeah, that one.
So you guys ready? Watch. More math B? Yes? Okay, one yes. And if there's one yes, then I think that since each of these things, these bases are being raised to the same power, I can look at the ratio of these bases, raised to that power. Yes, sir?
Where'd you get the extra n factorial on the top?
You know, this really came from taking the n plus 1 factorial and rewrite it as n plus 1 times n factorial. Are you sure you're okay with that?
Good, because in the previous example, you had 1 over n plus 1.
Yeah.
So that's why I was confused where the n disappeared.
No,
The one you erased. You said, ta-da, here's 1 over 1 plus 1 raised to the n.
I don't remember, I'm sorry.
Oh, that's okay.
I didn't look at it. Did you actually give me the answer?
Infinity?
Did I walk in the right
No,
place? I can-
Shouldn't go to infinity. 0.
Nothing.
All right, I'll put an extra step. I'll give you hints. Limit, as then increase that bound, let's look at the reverse that ratio. Is that a 1 over n plus 1 over n to the n?
0.
0.
No, not 0.
Sticking 0.
You're sticking with it.
1.
Now that's a dead giveaway.
Oh,
Thank you.
Oh, that's E, that's right.
Which is strictly less than 1. Therefore, my conclusion is,
How did you get 1 over E? I'm sorry.
well, don't you recognize this as an increase that bound is just e?
No. It's right here.
I derived out of math B.
Oh my god.
Oh, wait. Right. Ariel, I can go back.
What, I just can't read it.
But this is actually different, because it's 1 plus x over n
Sorry, I'll
to
write
the
it
nth
bigger.
power.
I meant 1 over 1
Simply.
plus 1 over n, all raised to the n power.
Go back to.
Yes, I can.
That one, yeah, is that a geoseries?
Is it a what kind?
Geoseries?
Oh, geometric?
With
No, only because what you see being raised to the nth power is not a constant. And since what's being raised to the nth power is not a constant, I can't subclassify this as geometric series.
Okay.
I'd like to, but it's more complex.
Because at n, I mean, no matter what n is, the denominator is always in positive numbers.
Oh, that's a good way of looking. I'm sorry, I didn't even see that. She's saying it's behaving like a geometric series because what's being raised to the nth power is always less than 1, no matter what it is. But nevertheless, I can't exploit the conclusion of that particular test
So
for
when,
geometric
so when
series.
we're
No.
using a geoseries.
You better have that R to be a constant.
Okay.
So, can you show me mathematically how that equals E?
Absolutely.
Yeah.
That was no pun intended.
Yeah.
Brad, stop me anytime. I'm just applying the French technique.
Okay.
Ah, but if this is 1, this one is 1, then I guess I've got this is equal to 1.
Yep. Alright, I remember that now. Yeah.
Sorry for the speed reading course, math 30.
We just did that a couple weeks ago too, I
Oh,
think.
did we?
Yeah.
I have no memory of it. And everybody, jeepers, I got a whole new test for you, but I'm only gonna give you one example because you won't see this nearly as often. And this is so darn specialized. It's called a root test. And the root test? It's not fair. I
It's
gotta-
non-existent.
I get to cheat. When it comes to root tests, Everything down below is exactly what you see with the ratio test. It's just that I got the nth root of a sub n period. Looks to me like I gotta clean that up today.
Yes, please.
I'm so sorry. So everybody, diving in. Notice how the conclusion is same, justification in 30 seconds. Let P sub n be this. Now raise each side to the nth power. I got P to the nth power. But that acts just like a geometric series. Further we go, P gets closer and closer to constant, like Linda was saying. And therefore, with a geometric series, same darn conclusions. Well, maybe not here, this one's inconclusive. So I think, in the last few minutes you have in class, when I go back to the last example I want to look at, namely question number 25, I just think you guys, 25 screams out at me that I want to employ the nth root, or the root test using, because something's being raised to the nth power. And the root test allows me to ignore the sign and ignore the nth power, period. In employing that root test, I will take a peek at the limit of the nth root of the absolute value of a sub n, which I think in this case is the limit. Is then increase that bound of, oh man, is it that fast? My goodness. What can you proclaim? Which is strictly less than 1. Therefore, by the root test,
Is that always absolutely with the root test?
well, with the root test and with the ratio test, if that thing ends up being strictly less than 1, you converge absolutely.
Oh, because of the absolute value signs.
Pretty there. I'm sorry I goofed up on that list, by the way. I never even noticed. I didn't have a root test in there. Yes?
Is absolutely something we're adding now, like on our exams?
Oh, on the final? Oh, yeah, but could you just not worry about till you dive in the homework? And a few questions I'm going to ask you in the homework said, does it converge? If it does it converge absolutely?
Isn't absolute convergence just means that if the absolute value of the series converges, then the series itself converges?
No, I think that's different. I think a series converges absolutely if, not only does it converge, but the series involving the absolute value of its terms converges as well. Okay, when I heard you say it in English, I heard you say this. If the series of the absolute value of n converges, then the series a sub n converges, which is true.
The series of the absolute value of a sub n.
Okay, I'll buy that then, yeah, sorry. I'm just being really careful with my language.
Okay. That's fair.
Well, you guys, I'm sorry I'm rushing at the end. Homework.